Hi everyone, today I'm gonna show about our project AI-based awareness grading system for food quality control. Before we start the project, I would like to introduce about my group member. Chong Yu Yi, Phung Kam Hao, Lin Yu Wei, Muhammad Afif bin Muhammad Rani, and me is Bing. Okay, let's start about extract. Currently, manual food grading by farmer is subjective slow and lead to massive post-harvest food waste, overripe food spoil during transit, while underripe one fail to sell. To solve it, our project arrived with UN Sustainable Development Goal 12 responsible consumption and production, focusing on reducing food loss across the supply chain. To fit this, we propose a low-cost AI-based grading system leveraging Google teachable machine and mobile net. We built a computer vision model that classifies food into three states: underripe, ripe, and overripe. Our goal is to provide small-scale farmer and retailer with a fast real-time software-only sorting tool to cut down waste and make smart inventory decisions.
Hello everyone, I'm Kam Hao and I will be presenting the framework of our AI-based grading system. The main goal of our grading dashboard is to analyze and display the ripeness status in a form that is easily understood. We designed this specifically so that farmers can use it even if they have no knowledge of programming and machine learning. Our system framework is built upon three core modules. First is the user input layer, where end user capture food image using mobile device, webcam, or static file upload. Second is front visualization, which utilize end visualization to display confidence score and actionable insight. Finally, the back-end machine learning engine, where our host teachable machine model processes the input through the mobile neural network to predict whether the fruit is under ripe, or over ripe. As figure 1, this is the overall architecture and data flow. The front end act as the primary medium between the user and the back-end engine. The user input is a raw fruit image which is transmitted to the backend. The teachable machine model process it and the ripeness prediction along with its confidence score and and return and visualize on the dashboard for the user to make actionable decision.
Hello everyone, I'm Lim Yue. I will be presenting the core engine of our project, the purpose predictive modeling. Our module consists of three major components. First is the data acquisition and pre-processing module. To ensure our computer vision model is robust, we utilize an industry standard platform called RoboFlow. We apply data augmentation techniques such as lantern rotation and brightness adjustment to train the module to handle different real-world lighting conditions. Additionally, for farms with unstable internet, we use a desktop application called Rover to curate and structure the dataset locally before uploading it to the cloud. The second component is model training. The pre-processed images are fed into Google's teachable machine. Our system employs transfer learning based on the mobile net architecture. The reason we choose mobile net is that it builds lightweight deep neural networks. heavily reducing the computational cost and model size. This makes it highly suitable for mobile and edge version applications where processing power is limited, perfect for an accessible, low-cost tool for farmers. Essentially, MobileNet acts as a powerful feature extractor and we append a custom dense layer to output the final probability for our specific classes. Finally, the third component defines the three distinctiveness categories based on visual patterns. The first is underlip. It characterized by liquid texture and green chlorophyll pigmentations. Second is lip. It characterized by the breakdown of chlorophyll, relieving yellow, orange, or red coloring. And the third one, overlip. It identified by melanin synthesis, causing brown spot and darkness patches. By integrating these three components, our predictive model can accurately and efficiently create fruit lipness. Thank you.
Alright, let's take a look at how our model performed and what this means for the future. When we tested the AI, it successfully beat our 80% accuracy goal. It was best at spotting unripe fruits, hitting a 93.5% precision because that solid green color is easy for the system to pick up. Ripe and overripe scored around 88 and 89%. There's a slight overlap since natural spots and shadows can look similar as fruit ages. So to help with this, our dashboard shows the exact confidence percentage. For example, it might say the fruit is 60% ripe and 40% overripe, so the user can easily make the final informed call. And to sum all this up, the accessible low-cost system takes the guesswork out of grading food for small-scale farmers and retailers. By reducing human error, we directly helping cut down on post-harvest food waste, which support Sustainable Development Goal 12. Down the road, we plan to train the model on much larger dataset with more fruit species and make it even smarter tool for the agriculture industry. Thank you.
Hi, sir. So for today, I want to show our project. Okay, for this teachable machine, I already trained the model for our project. So which is the project, the machine can define the class of the project. For this one is our unwrite project. And then this one is our write category. And this one is the override category. Okay, trend module. Okay, for this one, I use a file which is a picture. For example, download an Apple. For this one, page. And then I drop the image. Yeah, drop the image here. And this one. After that, the machine can define the Apple is an override category. So for example, I give another unwrite. The example unwrite orange. Okay, so I download this, save the image as. Then I drop the image this one. So you can define unwrite is the most percentage. Compare with the write and the overwrite. So for example, I give the overwrite or each orange. Then this one, save images. See. Then I drop the image from here. Something from that's all from my part. Thank you, sir.